Hello everyone, my name is Ariel Jones, and for this video, I'm going to be going over question 1 of exam 3. I know this one is a little lengthy. It's got about 12 problems, so I will do my best to go through it quickly, but also help it make sense. For your convenience, I printed out a unit circle instead of using the one that we filled in, just so that you could see that a little clearer, because this is the big key to solving these without a calculator. But for the purposes of demonstration, I'm going to show it so that we can check the work that I have on paper. If you can't see the papers too well, I will scan them into a PDF document and attach them with the video so that you can take a closer look. But some of the steps I explain, so the paper may not make all the sense that I'm doing in the explanation with the video. But I hope it's clear, and let's get through this. So we're finding the exact value for what we're given. So for A, we have sine of 3 pi over 4. And this one's really simple. So if we think back to the unit circle, sine of 3 pi over 4, but for simplicity, I will show you what we should be learning and have memorized on the unit circle. We're looking at 3 pi over 4. And the first value being the cosine, second value being sine. So the sine value for this one is the square root of 2 over 2. And that's our answer for A. Square root of 2 over 2. For B, it's the tangent of 4 pi over 3. So if we remember, tangent is sine over cosine. So what we're going to do is put sine over cosine, which sine of 4 pi over 3, if you're remembering back to your unit circle, the sine value is negative square root of 3 over 2, and the cosine value is negative 1 over 2. And we're going to simplify those. I simplified them by multiplying them by 2, and having the 2's cancel out. So here multiplied it by 2, negative 2 over 2 with the square roots of 3 in the numerator, negative 2 over 2 equals 1. So then that gave me the square root of negative square root of 3 over 1. And that was the solution for B. For C, so we're finding cotangent of C, and it's negative 7 pi. So cotangent is cosine of sine, or sorry, it's cosine over sine, not of sine. So for the 7 pi, if you'll remember that I had a hard time remembering, the pi value is here on the unit circle. So even if it's, 1 pi, 2 pi, 20 pi, this is what we're going to be looking at is coterminal angles, which are going to come into play a lot later. But anyway, but we're looking at the pi value there. So cotangent, anything at the cosine is going to be negative 1 because that's the value of cosine at pi. But the sine value at pi is always going to be 0. And since we can't have a 0 in the denominator, it's going to be undefined for this function here. So I hope that one makes a little bit of sense. For D, we have the inverse of cosine, so of negative square roots of 3 over 2. So now this one, we're going to kind of think backwards is how I think about it. So we have cosine. So we have where cosine is equal to negative square roots of 3 over 2. Sorry, I got to double check because I'm looking at it backwards here. And if you'll see, we actually have two values where we get the negative square roots of 3 over 2. We get it at 5 pi over 6, and we also get it at 7 pi over 6. So which would, be like, well, there's two places where it fits the value. But we also have to look at the bounds of these equations because since they are functions, for example, normally cosine is not a function in itself. So we have to look at it within a certain set of bounds so that it fits the functions. So it fits the definition of a function. Same thing with sine and all of the others. We're looking at them within a certain set of bounds. So with the inverse of cosine, we're trying to find the inverse of cosine that fits this particular value that is also within the bounds. And that would happen to be 5 pi over 2? Sorry, 5 pi over 6. I can't even read my own writing. Looked at this for too long trying to solve it. So that's the first value that fits it. This one isn't in our bounds. So therefore 5 pi over 6 is going to be our answer for that problem. Okay, gotta breathe. Moving on to the next couple sets. I hope you're still staying with me here. So for this one, we have secant of inverse sine, sorry, excuse me, that's an inverse of 1. So what we are going to be doing for this one, I separate it out into the inverse of sine of 1. Sorry, I should have kept that back up here. Where'd it go? Sine. So we're going to find the inverse of sine is 1. So I have that as being pi over 2. So what we're going to do is kind of work backwards, since it's the inverse, instead of giving us the value here, we are plugging it backwards. So we are given sine of 1, and the first place where sine of 1 exists is pi over 2. So that gives us the inverse value of sine of 1. And then we take the pi over 2 and we find the secant of pi over 2, which secant is 1 over cosine. So then we plug in 1 over cosine of pi over 2. Cosine of pi over 2, if we take that back here, cosine of pi over 2, the first value is 0. So that's going to make our cosine value 0, which is going to give us 1 over 0. And once again, that's an undefined function because we can't have a 0 in the denominator. Moving on, for number f. Sorry, I know I'm getting winded here. So for f, we have cosecant of 7 pi over 2. So what cosecant is 1 over sine. So what we're going to do is 1 over sine of 7 pi over 2. So we're going to plug this value into our sine, which is in the denominator. So then we have 1 over 1/2, because if we remember, thinking back to the unit circle, 7 pi over 6, the value of 7 pi over 6 is going to be a -1/2. You see that? Yeah, is going to be a -1/2. So like we're supposed to know it on the unit circle, but like I said, I am showing it so you can see, double check where I'm getting my values from. So we reduce that down. I multiply both sides by 2. I get 2 over -2 over 2, which cancels out to 1, 2 over -1, which equals -2 for the value here. So G is cosine of -pi over 2. This one is one of those pretty straightforwards. Oh, I'm losing my paper now. I have 50,000 papers. So -pi over 6. And once again, this one is one of those the ones that fall within the bounds that we have to consider, which is going to be the square roots of 3 over 2 for letter G, because we always have to consider the bounds of the functions that we are looking in. So for letter H, tangent, the inverse tangent of 0. So we have tangent, inverse tangent, sorry, a little getting tongue-tied now. Tangent, inverse of 0. Tangent, you know what I mean, sorry. So tangent is sine of cosine, which we have the y value and the x value for this one. So this one I kind of had to think a little bit backwards and find the value where tangent is going to equal 0. Well, if this equals tangent, the sine over cosine, we need to find the first place where these are going to equal out to be 0, which if we look at our unit circle, the first place is actually going to be at 0, because we have the cosine is 1, which the cosine is in the denominator, and the sine can be 0. As long as the 0, since we're not solving for sine in the denominator, it's not undefined. But the 0 can be in the numerator. The 0 can be in the numerator, which this equals out to 0, which this is kind of a backwards way to solve the problem. Instead of just looking at it this way, I kind of decided to see at what point is this 0. At what point can we make this value 0? Because technically pi, also technically pi could be a solution for it as well. But once again, that's why it's so important to understand the bounds of these particular functions. So that lets you know that the answer for that one is 0. Ooh, okay, only 4 more to go. We can do this. I hope I'm making sense. So for letter I, we have secant. And we have secant of 14 pi over 3. And if you're like me, you just see the 14 pi over 3. It doesn't look like anything familiar, so you panic and skip over it. Which is kind of what I did. But I didn't really understand the whole point of when something, let's call it, doesn't look familiar. That's when you make it into something that you recognize, or that's how I think of it. It's probably not the technical term, but that's what I like to think. So since secant is 1 over cosine, we're going to look at this half, and then we're going to plug it back in into the 1 over cosine. But for right now, we're going to look at cosine of 14 pi over 3. Well, 14 pi over 3, as I said, it doesn't look familiar. There's nothing on the unit circle that we can tie it to. So we need to find an angle that it's coterminal with. And this is where the coterminal angles really play a role in this, because if there's something that this isn't showing up, we can keep subtracting 2 pi from it until it starts to look familiar, as I like to say, and then find the value given to us for that. So when we first subtract 2 pi from it, we're going to get 8 pi over 3, which, once again, that's not something that looks familiar. So let's subtract another 2 pi from it, which that's actually going to give us 2 pi over 3. And 2 pi over 3 is a value that is here on the unit circle. So then we're going to go back and we're going to plug, the 2 pi over 3 into cosine. And 2 pi over 3 of cosine, going back to our in unit circle, 2 pi over 3, the cosine value is -1 over 2. So then we have the cosine value of -1 over 2. Make sure you can see this. And then since we are actually solving for the secant, which is 1 over cosine, it's going to be 1 over -1 over 2, which I multiplied both sides by 2 and reduced it down and then got -2. So -2 is the value for that. Whew. So for J, what we're going to end up looking at, this one also caused me a bit of a problem, because it's the cotangent of the inverse of cosecant. Oh, sorry, did I call this one cosecant? This one's cosine, and this one's cosecant, but sometimes I look backwards. Sorry, this one should be cosine if I started calling them every which name at this point. They're all blurring together. Sorry. Okay, cotangent of cosecant. The inverse of cosecant of 2. So what we need to do is look at the cosecant. I'm going to look at that one first before I even compare it to the cotangent. So I have 1 over sine, 1 over sine of 2. So what I'm trying to see is where this equals, where this one is going to equal 2. And in order for the cosecant to equal 2, that means that that this sine value is going to have to give me something, being the denominator under 1, that's going to give me 2. And the first thing that's going to do that is a sine of a half. Because if we have 1/2 in the denominator, then it's going to equate to 2. So the first place where sine is 1/2 is pi over 6. That's where we're going to get that value. Like I said, for me, sometimes I have to think backwards in a problem to solve it in reverse in order to understand what the solution is. So maybe that'll help somebody else too. So now we're going to plug it into the first half of the equation, which is cotangent of pi over 2. And since cotangent is cosine over sine, we're going to look at pi over 2. The value of pi over 2 at cosine is square root of 3 over 2. And the value of sine at pi over 6 is 1 over 2. I multiplied both of these by 2, reduced them out, and that gave me the square root of 3 over 1. So hope that one made a little bit of sense. I know it's a little lengthy. Whew. So now we are on K. This one, I think by far gave me the most issue that I had with. So we're getting the inverse of sine equals -1 over square root of 2. So I have to double check my notes on this and to be sure I'm explaining it right. So since this, once again, it doesn't look familiar, which is kind of what I feel like in order to compare it to the unit circle, it's got to look familiar. So I decided to multiply it by the square root of 2 over square root of 2, which is the same thing as multiplying it by 1, but it'll give us a different form to see it in. So multiplying it by square root of 2 over 2 is going to give us square root of 2 over 2. Sorry, it reduces out to negative square root of 2 over 2. It's really hard to read these backwards on the paper that I just wrote. And this actually equals pi over 4. So the inverse value of sine of this is going to be pi over 4. And that's just kind of by changing the way it looks, once again, into something familiar so that we can solve for it. Because finding the sine, finding the negative 2 over 2, is going to give us a pi over 4. Once again, understanding the bounds of the sine function. Last but not least, letter L, we have cotangent of 11 pi over 4. Cotangent being cosine over sine. Once again, 11 pi over 4 doesn't look familiar. So then we have to subtract it, and we have to subtract it and find the values in order to get a coterminal angle, because while this is technically an angle we can work with, it's not one of the familiar ones. So if we subtract 2 pi by this and calculate this one out, it's going to give us 3 pi over 4. Oh, sorry, can't even see that. 3 pi over 4, and that's one of the familiar ones. So the cotangent of 3 pi over 4. So what I did was went to this point in the unit circle, 3 pi over 4, and for the cosine value there, it's square root of 2 over 2. And the sine value of there is square root of 2 over 2 as well. Oh, sorry. Let me double check. Square root of 3 over 4. Yes, sorry. The cosine value is negative. Let me be sure. My negative value got lost in my square root. So that's negative. So it will reduce to essentially negative 1 over 1, which reduces down to negative 1. So negative 1 is the value for cotangent. So hope that made sense. Once again, I'll submit these copied in with the video, and I hope you're able to understand how to get those values without a calculator. I use the unit circle for a reference, but if we haven't memorized, then it's a lot easier to just draw from it and be able to pick it for ourselves than having to continually look back at the page a dozen times, because it's not only helpful in this, but in everything else we've been doing lately. So thanks for watching.